The following is a narration from the Estero Fire Rescue Firefighter Manual, revised on 9/23. Chapter 1, Estero Fire Rescue. Station 41, located at 8631 County Road. Estero Fire Station 42, located at 8005 Sweetwater Ranch Boulevard. Estero Fire Rescue Station 43, located at 21510 Three Oaks Parkway. Estero Fire Rescue Station 44, located at 21300 Firehouse Lane. Estero Fire Rescue Station 45, located at 18743 Corkscrew Road. Fire Apparatus Station 41, Ladder 41, Sufton. Model SL75, ID 16-002, height 10 feet, length 41 feet 8 inches, wheelbase 232 inches, fuel type diesel, water capacity 470 gallons, foam capacity 30 gallons, vertical reach from the ground 75 feet, horizontal reach 67 feet, tip load wet 750 pounds. Tip load dry, 1,000 pounds. Ladder 49, Sufton. Model number SL75. ID number 12-001. Height 10 feet. Length 39 feet 9 inches. Wheelbase 232 inches. Fuel type diesel. Water tank capacity 470 gallons. Foam tank capacity 30 gallons. Vertical reach from the ground 75 feet. Horizontal reach 67 feet. Tip load wet, 750 pounds. Tip load dry, 1,000 pounds. Brush 41, make, Ford F550. ID number 99-402. Height, 7 feet 9 inches. Length, 21 feet. Fuel type, diesel. Water tank capacity, 400 gallons. Foam tank capacity, 10 gallons. Station 42, Ladder 42. Make, Sufton. Model, SL100. ID number 24-001. Height 10 feet 2 inches. Length 43 feet 7 inches. Wheelbase 236 inches. Fuel type diesel. Water tank capacity 350 gallons. Foam tank capacity 30 gallons. Vertical reach from the ground 100 feet. Horizontal reach 91 feet. Tip load wet 750 pounds. Tip load dry 1,000 pounds. Rescue 42. Make Chevrolet Suburban. ID number 16-001. Height 6 feet 6 inches. Length 19 feet 5 inches. Fuel type gasoline. Marine 40. Make Sabalo 27 feet. Engine 350 Mercury Verado. ID number 19-001. Length 27 feet. Fuel non-ethanol gas 90-gallon fuel capacity. Foam tanks 3 5-gallon buckets. Station 43, Squad 43. Make Sufton. Model Monarch. ID number 13-001. Height 11 feet 6 inches. Length 34 feet 9 inches. Wheelbase 232 inches. Fuel type diesel. Water tank capacity 750 gallons. Foam tank capacity 30 gallons. Battalion Chief 40. Make Chevrolet 2500 HD. ID number 14-001. Height 6 feet 8 inches. Length 21 feet. Fuel type gasoline. Utility 43. Make Honda Pioneer S by S 1000. ID number 16-004. Height 6 feet 5 inches. Length 12 feet 2 inches with stretcher. Fuel type gasoline. Support 40. Make Chevrolet C4500. ID number 07-002. Height 11 feet 7 inches. Length 24 feet. Fuel type diesel. Air 40 trailer. Make Mako. Model 5407 HBA-WOT. ID number 07-005. Height 7 feet 7 inches. Length 15 feet 6 inches. Fuel type diesel. Station 44, Engine 44. Make Sufton Monarch. ID number 20-001. Height 10 feet 1 inch. Length 32 feet 8 inches. Wheelbase 192 inches. Fuel type diesel. Water tank capacity 750 gallons. Foam tank capacity 30 gallons. Brush 44, make Oshkosh, model number MPT1823, ID number 00-204. Height 11 feet. Length 24 feet 6 inches. Fuel type diesel. Water tank 750 gallons. Foam tank none. Tender 44, make Kenworth T300. ID number 07-001. Height 9 feet 8 inches. Length 30 feet 2 inches. Fuel type diesel. Water tank capacity 3,000 gallons. Station 45, engine 45, make Sufton Monarch. ID number 22-001. Height 10 feet 1 inches. Length 32 feet 8 inches. Wheelbase 192 inches. Fuel type diesel. Water tank capacity 750 gallons. Foam tank capacity 30 gallons. Brush 45 LMTV. ID number 18-001. Height 10 feet 6 inches. Length 23 feet. Fuel type diesel. Water tank capacity 700 gallons. Brush 45 has no foam tank. Engine 49 spare. Make Sufton Monarch. ID number 13-002. Height 10 feet 3 inches. Length 33 feet 8 inches. Wheelbase 204 inches. Fuel type diesel. Water tank capacity 750 gallons. Foam tank capacity 30 gallons. Marine 45. Make INMAR. Model 430MI HDS. ID number 23-004. Length 14.5 feet. Motor Mercury 25 horsepower. Fuel non-ethanol gasoline 6.5 gallons. Utility 45 Polaris Ranger. ID number 23-001. Height 6 feet 5 inches. Length 12 feet 6 inches. Fuel type gasoline. Zone familiarization. Major roads leading east and west. Corkscrew Road, Estero Parkway, Broadway, Williams Road, Coconut Road. Major roads leading north and south. I-75, US 41 Tamiami Trail, Three Oaks Parkway, Ben Hill Griffin Parkway, River Ranch Road, Alico Road. Major subdivisions in 41 Zone. Breckenridge, Broadway Village Mobile Home Park, Cascades, Covered Wagon Mobile Home Park, Cypress Bend Mobile Home Park, Estero Bay Village Mobile Home Park, formerly known as Tahiti Village, Estero River Estates, Estero River Heights, Genova, Groves, Mariners Cove, Pelican Sound, Riverwood Plantation, Sunny Grove Mobile Home Park, Terra Vista. Major subdivisions Zone 42, Coconut Shores, El Dorado Acres, Fountain Lakes, Marsh Landing, Meadowbrook, The Meadows, Pelican Landing, Rapallo, Residence at Coconut Point, Shadowwood, Spring Creek, Spring Run, The Colony, The Hyatt, The Tides, West Bay Club. Zone 43 Major Subdivisions. Coastal Village Apartments, Colonial Oaks, Copper Oaks, Copperleaf, Corkscrew Woodlands, Country Creek, Courtyards at Estero, Estero Oaks, Estero Palms, Estero Place, Heatherstone, Island Club, Lakes of Estero, Lighthouse Bay, Oaks of Estero, Pebble Point, Rookery Point, Shadowwood, The Reef, Villa Palmeras, Villaggio, Island Club. Zone 44 Major Subdivisions. Corkscrew Estates, Corkscrew Preserve, Grandeza, Stony Brook, Waterline Estero, Wildcat Run, Corkscrew Ranch, Corkscrew Shores, Tidewater, Wild Blue, Zone 45, major subdivisions, Corkscrew Estates, The Place, Old Corkscrew, Veranda Village, major commercial buildings, target hazards. Zone 1, Estero Medical Center, Walmart. Zone 42, American House, Bonita Community Health, Coconut Point Ford, Coconut Point Honda, Coconut Point Mall, Gull Point, Hertz Headquarters, Lee Health Coconut Point, Life Care Center of Estero. Zone 43, AutoZone, Estero Bay Chevrolet, South County Library, Lowe's, Post Office. Zone 44, Corkscrew Water Treatment Plant, Hertz Arena, Miramar Design Center, Miramar Outlet Mall. Zone 45, Alico Road Water Treatment Center, mid-high-rise buildings 75 feet or higher, Embassy Suites, 7 floors, Hampton Inn, 5 floors, Hyatt Coconut Plantation, 4 floors, 3 living, 1 garage on first floor, Hyatt Place, 5 floors, Hyatt Regency, 22 floors, Osprey Cove, 4 floors, Spring Hill Suites, 5 floors, The Colony, Altera, 21 floors, Cielo, 5 floors, 4 living, garage on first floor, Navona, 23 floors, Sorrento, 21 floors, Treviso, 22 floors, Florencia, 22 floors, West Bay, Jasmine Bay North, 21 floors, Jasmine Bay South, 21 floors. Acronym to remember for The Colony: No Smoke to Fight Against. Colony High-Rise Pneumatic, approaching from Coconut Road. Chapter 2, Building Construction. Building Materials. Cedar block, 8 inches by 8 inches by 16 inches. Wood studs, nominal 2 by 4, actual 1.5 by 3.5. Nominal 2 by 6, actual 1.5 by 5.5. Nominal 2 by 8, actual 1.5 by 7.5. Oriented strand board, OSB, a type of engineered wood similar to particle board, formed by adding adhesives and then compressing layers of wood strands or flakes in a specific orientation. Plywood is made from thin sheets known as veneers, glued together, each with its grains in perpendicular directions in altering layers to improve the strength and minimize the movement in the plane of the board. Drywall, half-inch drywall. Half-inch drywall is the most common drywall thickness. It's commonly used for walls, ceilings, although it's a little too thick for most curved walls. 5-inch drywall. Because of its added strength, it's often used in ceilings to prevent sagging between the ceiling joists. The extra thickness also makes it ideal for using it on shared interior walls, such as those between separate apartment units. Most fire-resistant drywall is 5/8 inch thick. A version of 5/8 drywall is known as Type X or Fireboard, and these have glass fibers in the construction. This is commonly used for places like stairwells, corridors, and garage ceilings, and will reduce flames from spreading in the event of a fire. Colors, and what do they mean? White drywall, standard. Green drywall, moisture resistant. Purple drywall, mold resistant. Pink drywall, fire resistant. Blue drywall, soundproof. Type 1. Type 1 construction, fire resistive. In this type of construction, the structural elements consist of non-combustible materials, usually steel or concrete, that afford a fire resistance rating that provides a given fire protection performance against the effects of fire. These specific ratings are determined by the model building codes for a specific type of construction. These specific ratings apply to the roof and floor assemblies, as well as any exterior or interior bearing support walls. Interior partitions are required to be constructed with approved non-combustible materials. Fire-resistive ratings are provided by different designs that meet minimum performance: drywall, sprinklers, and spray-on coatings. Type 2 construction, non-combustible. The same requirements apply to Type 1 construction also apply to this type of construction, with some differences. This type of construction may not afford any fire resistance rating for the exposed structural elements. If any fire protection of the structural elements is provided, it is at a lesser rating than required for Type 1 construction. In this type of building, the structural elements are usually made of steel, bolted, riveted, or welded together. This type of construction is susceptible to expansion, distortion, or relaxation of the steel members, resulting in early collapse during a fire. Again, interior partitions are required to be constructed with non-combustible or approved limited combustible materials. Type 3. Type 3 construction, ordinary construction. Type 3 construction, referred to as ordinary. In this construction type, all or part of the interior structural elements may be combustible. Exterior walls are required to be constructed with non-combustible materials. They can have a fire resistance rating depending on the horizontal separation and whether they are bearing or non-bearing walls. This category is usually divided into protected and unprotected subtypes. The building will have masonry exterior walls and wooden structural members and combustible interior construction. The building generally will not exceed 6 stories and most often will be 2 to 3 stories in height. Floor and roof supports are usually wood, but other materials, such as steel bar joists, may be found. The floor and roof decking most frequently will be plywood or composite board. Common walls between buildings may share wall sockets for floor joists and roof rafters. Type 4 construction, heavy timber. Heavy timber structural members, columns, beams, arches, floors, and roofs are unprotected wood with large cross-sectional areas. A minimum dimension of 8 inches for structural wood supports, columns, beams, arches, and girders are required. All other exposed wood must have a minimum dimension of 2 inches. Concealed spaces usually are not permitted. These buildings consist of masonry, non-combustible exterior walls, and structural members of substantial timber construction. Commonly, this type of construction is found in older factories and mills. However, there is a resurgence in their use in various new occupancy types. Wood floors generally will have a minimum thickness of 3 inches and may be oil-soaked from years of oiling heavy machinery. Roof supports will be wood with minimum dimensions of 4 by 6 inches and a minimum roof decking thickness of 1 1/8 inches. Type 5 construction, wood frame combustible. This type of construction uses structural members entirely of combustible materials, usually wood, and is divided into 2 subgroups: protected structural elements protected as required, or unprotected, no fire resistance requirement. Post and beam construction has a wood frame of substantial dimension and is sided with a lightweight covering such as wood boards or plywood covered with aluminum or PVC siding. This type of construction is usually used for barns, sheds, and other storage buildings, but also may occur in dwellings and other occupancies. In balloon frame construction, studs from the foundation to the attic. This type of construction was common in many parts of the country until the late 1930s. For residential and lightweight commercial buildings. This provides a continuous airspace from top to bottom. Floor joists are tied into the wall, allowing for fire extension in any direction. Fire stopping was not common practice. In platform frame construction, the walls of each successive story are built on a platform, formed by preceding 4. The joists of the deck may be full-dimension lumber or lightweight materials. Once the floor or deck is in place, walls are placed on it with a sill at the bottom of the wall and a plate at the top. Platform frame construction provides a neutral fire barrier for vertical extension within the walls, but openings in the walls for water, sewer, ventilation, or heating air conditioning pipes can create a void for fire extension. Modern construction uses assemblies and structural systems comprised of engineered components with a continuing advancement of new materials, designs, and structural and architectural integration. Residential building construction, 1-story CBS, concrete block stucco. Type 3 construction, ordinary, on a slab foundation, rebar reinforced exterior walls. Trusses are tied to the walls, identifiable by inset windows. If there's a second floor, that usually has wood walls. If there's a second floor, watch for lightweight truss floors. 2-story CBS, concrete block stucco. Type 3 construction, ordinary. Type 5 construction, wood frame, second floor. On cement slab foundation, rebar reinforced exterior walls. Trusses are tied to the walls. Identifiable by inset windows. If there's a second floor that usually has wood walls, look for flush windows or siding as an indicator. If there's a second floor, watch for lightweight truss floors. Wood frame, type 5 construction. Wood frame often has a crawl space. Keeps wood off ground from rotting. Look for steps into the house. Identifiable by windows flush to the walls. Look for siding. Variation is stilt home. Multifamily residential construction, CBS, concrete, block, stucco, type 3 construction, ordinary. On cement slab foundation, poured slab floors. With rebar reinforced exterior walls. Trusses are tied to the walls. Identifiable by inset windows. Wood frame, type 5 construction, wood frame. Identifiable by windows flush to the walls. Stairways and hallways can be concrete. Be suspected of hidden fires and extension in other apartments. Residential roof. Construction. Ordinary standard is 24 inches on center of spacing from trusses. Commercial roofs. Commercial roof construction has many possibilities, ranging from pinolized to lightweight pinolized roofs with minimal burn time. The roof decking may be made of a variety of construction materials. These roofs should be pre-planned and understood prior to the incident even occurring. Horizontal and PPV ventilation can be tricky in these buildings. Large openings and headspace make it difficult to pressurize and control. The headspace tends to make the smoke swirl and go back up with the PPV. Sometimes the best method is to open the building as much as possible, and as the smoke cools, it will fall out of the building. If the roof is strong enough and conditions warrant vertical ventilation, consider sending multiple companies to the roof. One company may not be enough. Metal deck roof. Caution must be taken when working above and under metal deck roofs. Often, the metal used for construction is thin. The strength may be increased from a layer of concrete. When the metal deck roof is exposed to heat, the metal can expand and crack the concrete. It is difficult to determine where the roof joists are located when making a ventilation cut. Some metal deck roofs have tar on top of the material decking. When fire exposes the underside of the metal deck roof, the tar is heated and can rain down onto contents below. This could quickly advance the fire. When dealing with fires involving metal deck roofs, the danger of sudden roof collapse in large sections must be considered. Steel truss joists. Steel trusses can twist and fall under fire conditions. The steel is often exposed from the underside. A significant fire can quickly damage steel trusses, leading to a catastrophic failure. Open web trusses can be made with both wood and tubular metal. Engineered wood I-beam trusses can stretch long spans, but can degrade quickly under fire conditions. Building construction terminology. Structural loads. Structures are designed to carry loads and, as such, are under extreme pressure or stress to keep their associated forces neutralized. Loads can be described in 3 general categories: dead loads, impact loads, and live loads. Dead load. Dead loads. These are static forces that are relatively constant and can be under tension or compression. Examples include the construction elements themselves, such as walls and roofs, or additional fixed items, such as air handling units and boiler and heating assemblies. It is important to understand that dead loads contain many items not ordinarily thought of as structural, such as plumbing stacks and risers, electrical boxes, heating, ventilation, and air conditioning systems. Even fire sprinkler arrangements can be thought of as part of the building's dead load. A firefighter needs to understand dead loads as the largest amount of the building's structural strength and subsequent weight, and the lethal consequences of their failure during a fire. Impact loads. These are the loads associated with moving heavy machines, vehicles, or stored merchandise inside a structure. The random movement of elevators can be described as an impact load. Such movement during a fire can collapse a building without any structural indicators, such as a softening roof or spalling concrete. Live loads. These loads include dynamic loads such as people, furniture, and weather. These types can become critical in times of emergency or disaster, especially as they increase in scope and scale. Evacuation of panicking civilians may become a primary initial tactic, and high winds can render master streams useless, putting interior crews at increased risk. Forces, power, and direction. Load forces are difficult to define and predict. A firefighter can think of force in three ways: concentrated force, linear force, and distributed force. Concentrated force. These are concentrated loads that are single forces acting over small areas, such as a column or a beam resting on another beam. An active fire at one of these point locations can initiate a complete ceiling collapse. Linear force. These are line loads that act along a line such that the force of the load reveals along that line. The weight of a bearing wall on a floor is a good example of a line load. Fire hidden in the floor joists, under surface coverings or carpet, wood or tile, and adjacent to the bearing wall can result in particular or full floor collapse. Distributed force. This involves a load carried over a large area, such as windstorm on siding or snow accumulation on a flat roof. Adding to the load of a building by subjecting it to high winds or additional 6 inches of snow or rain during a fire can change the parameters of a collapse dramatically. Stress. Regardless of the types, loads are transmitted throughout the structure as stress, and stresses are imposed on structural materials by force. The stresses on a construction materials are defined as compression, tension, and shear. Compression, a direct load on a column or wall. Firefighters should watch for where a room or building is weakest, such as a glass wall with no partitions or a bearing wall separating the kitchen from the dining room. Tension, a load that pulls on another structural member, like the forces between turnbuckles. These loads can be seen in curved roof assemblies and in pre-stressed concrete construction, where complete walls have been placed in a connecting pattern relying on a little or no additional structural framing. Shear. Shear energy is a stress on a horizontal bolt connection, two vertical metal roof sections. While fire can compromise such assemblies, weight and shifting forces can also contribute to the shearing failure, providing no direct indicator for a rescue or suppression crew. Electrical meters on structures doesn't mean that there is no power. There might be an illegal hookup powering. When looking at a multifamily structure, use the number of meters to help figure out how many units there are. Often, there will be 1 meter for the common grounds and then one for each unit. There are shutoffs for the whole building on each unit. Just because a meter does not exist on a structure does not mean that there is not power to the house. There might be illegal hookups powering the house. Air handlers, number one cause of smoke and odor emergencies. Normally occurs during the first few cold snaps due to dust accumulating on the heat coils and causing smoke when they burn up. Located in the air handler. Secure power to the AC, heat, and air handler. Open the handler with a 1/4-inch hex and 5/16 hex. On one side, it will be the condenser. The other side will have the motor and belts. Look for evidence of burning dust, wires, and other problems. Chapter 3. Hand tools. Categories of hand tools. Cutting tools. Examples are axes, saws, and bolt cutters. Prying tools, such as haligans, pry bars, and crowbars. Pushing, pulling tools. Roof hook, pike pole, universal hook. Striking tools. Sledgehammer, flathead axe. Specialty tools. Lock pulling. Axes, used for striking. 8-pound flathead axe. The 36-inch force axe is a working axe versus a cutting axe and is the ideal tool for the sort of striking on a halligan or crowbar or padlock breaker. The force axe has a large hitting surface measuring 1.5 inches wide and 3.5 inches high, much larger than a 6-pound axe flathead. The large oversized head makes the strike zone more accurate, easy to hit, and maximizes each strike. The cutting edge is hardened to keep its edge longer. The head of the force axe is creatively designed to also act as a wedge to get under, around, and in door jambs for door control, leverage, and other techniques. At its widest point, the axe head measures 1.5 inches. Midway, it measures 1 inch, to just before the tip, where it measures a 1/4 inch. 8-pound lock slot. The lock slot 8 features a dropped forged head of high carbon steel, Rockwell heat treated and coated with anti-rust nickel plate. The marrying slots lock the maximus to the axe for easy carry by one hand. No strap needed. The lock slot 8 has a triple strength 32-inch fiberglass handle with a deer's hoof knurled bottom grip. 6-pound flathead axe, also known as the Boston flathead axe, has an extra long yellow axe handle with a deer's foot handle, standard 36-inch handle. 6-pound pickhead axe, Boston pickhead axe, 6-pound, extra long yellow axe handle with a deer's foot handle. Sledgehammer, 8-pound, sledgehammer with 28-inch fiberglass handle for forcible entry, protected handle for overstrike and self-extinguishing Caltex grips. Halligan tools, Pro-Bar. The Pro-Bar is 30 inches long and is drop-forged, one-piece construction of alloy steel. The Pro-Bar, also called the Halligan bar, or the Halligan tool, or simply the Halligan, is a special tool commonly used in the fire and rescue service. It was designed and named after Hugh Halligan, a first deputy fire commissioner in New York City Fire Department. The Halligan is a multi-purpose prying tool consisting of a claw or fork, a blade or adze, and a pick, which is specifically useful for quickly breaking through many types of locked doors. Max Mod, a completely tuned 30-inch Halligan, one-piece, drop-forged, forcible entry tool made of 4140 chrome vanadium steel, 2-inch wide adze for gapping doors, square tops of the fork for striking in tight entry operations, thin adze, and fork. Adze and fork have depth gauge markings. The Max Mod is almost 2 pounds lighter than a Halligan Pro-Bar. Maximus Rex, Max Rex, a completely tuned 30-inch Halligan, one-piece, drop-forged, forcible entry tool made of 4140 chrome vanadium steel, 2 3/4-inch wide adze for gapping doors with a Rex-style lock puller cut into the adze, square tops of the fork for striking in tight entry operations. Adze and fork have depth gauge markings. The Maximus Rex is almost 2 pounds lighter than a Halligan bar. 3-piece Hooligan, older style Halligan type tool that we had phased off all primary apparatus. This is a pinned 3-piece tool with straight adze and a fat fork end. Lock pulling, officer's tool, a tool, a personal size officer's tool that pairs with a pry bar at one end with an A-type lock puller and adze at the other. A key tool for through the lock is mounted in the grip. K-tool, carried in a leather pouch. The K-tool is a lock pulling device that needs to get married to the Halligan to be used. Pouch should include set of 3 keys. Key tool, 5/32, square hex, key, and shove knife. Pulling tools, 6-inch New York roof hook. The New York roof hook is essentially the head of all-purpose hook with a chisel to allow for light prying and made with aircraft steel for strength. Primary pulling tool for overhaul, finding hidden fires, and primary tool for OV when paired with a Halligan. 8-foot New York hook, slightly longer for homes with taller ceilings. 6-foot Lockwood hook, improved version of the New York hook roof. 5-foot Lockwood hook, engineering OV tool, married with a Pro-Bar. 6-foot pike pole, a strong conventional hook for quick and effective removal of ceilings, walls, moldings, doors, and window frames, made of a fiberglass shaft which makes it lightweight. 8-foot pike pole, a strong conventional hook for quick and effective removal of ceilings, walls, moldings, door and window frames. A fiberglass shaft makes it lightweight. 10-foot and 12-foot pike pole, a strong conventional hook for quick effective removal of ceilings, walls, moldings, doors and window frames. A fiberglass shaft makes it lightweight. A New York hook at this length would be too heavy to be effective. Trash hook. This hook was developed to find hidden fires and deep-seated smoldering fires, normally found in dumps or dumpster fires. A normal hook just won't pull trash in large quantities. Because of the trash hook's large 6-inch pointed prongs, it will grasp debris in large chunks. Closet hook, a short hook specifically designed for drywall removal of all types, can be used on other materials such as wood, plaster, sheet metal walls, and ceilings. Design allows for conventional penetration, an arc hook, exceptional pry action, combination rake and hoe. Bolt cutters, useful and effective tools for numerous cutting situations, including padlocks, bolts, chains, and rods. Bolt cutters will not cut case-hardened steel. EFR carries a 30-inch bolt cutter. The Hydroram, manual hydraulic tool, 11 pounds, and has a thrust opening of 6 inches, capable of 10,000 pounds of force. Chapter 4. Hand saws. Chainsaws. Steel chainsaws. MS-361. MS-362. Has an 18-inch bar and uses True Fuel premix fuel. Chainsaw blades. Rapco carbide tip chain, frontline units. Steel standard wood cutting chain, used for brush trucks, and spare on frontline rigs, used for cutting trees. Daily inspection. Is the chain clean? Is the chain on correctly? Does the saw look in working order? Does the brake work and is the chain tensioned properly? Correct tension. Just a little loose on bar. Can't pull drive links out of bar. If the chain is too loose, it will come off the bar. If the chain is too tight, you'll meet too much resistance. To adjust chainsaw blade, slightly loosen 2 nuts and then insert screwdriver head of the scrench to middle hole. Tighten or loosen as needed, then tighten nuts. Start the saw. The saw's chain should not spin while the saw is idle. If it does, it is a sign of a dirty clutch. Take the saw out of service and right it up. After use, check the air filter, fuel, oil, and clean the chain. Be sure to tension the chain. A detailed inspection of chain and bar is required. If anything is dirty, pull the cover and thoroughly clean the area around the brake, as well as the clutch and the underside of the plate. Hot soapy water, high-pressure air, or a solvent such as WD-40 or carb cleaner will work just fine. Close the choke prior to this and make sure air filter stays dry. Procedures for starting saws. While the brake is engaged, use full clutch until the engine begins to fire. Move the choke up 1 click to the fast idle position. When the saw starts, release the trigger and the engine to idle. At this point, disengage the chain brake. Allow the saw to warm up before operating at top speed. Usually, this can be accomplished in 1 minute. Allow the saw to run at mid-range for 30 to 45 seconds before bringing it up to full throttle. Run at full throttle for 10 to 15 seconds. This is a sufficient amount of time to make sure the oiler works properly. The saw will only oil when the chain is spinning, and it will oil at any speed. This is a very good way to get the bar and chain re-oiled after cleaning. This will prevent wear and heat damage to a dry bar. If the chain and bar are oiled correctly, now it is time to bring the saw up to full speed safely. Allow chainsaw to return to idle speed prior to turning off. Rotary saw, forcible entry. The Stihl TS510, the TS700, and the MS5700. A 20mm arbor, runs at 5,700 RPMs and weighs 25.6 pounds. Rotary saw, forcible entry, the Husqvarna K12FD970. Details: will fit a 12-inch or 14-inch blade, has a 1-inch arbor, runs at 5,500 RPMs and weighs 24 pounds. Rotary saw blades: diamond, carbide, tungsten tip multipurpose. Husky Fang, cuts metal, locks, bars, concrete, steel, roll-up doors. This is not a wood cutting blade. Requires a spacer to fit correctly on the K12. When checking diamond blades, check for cracks in the vanes. This can indicate weakening of the blade prior to failure. Steel abrasive disc, cuts metal, roll-down doors, garage doors, metal hurricane shutters. No spacer needed. Will get smaller as you cut. May not be able to cut all the way through garage door bracing towards the end of the cut. Starting the rotary saw. Saw should be turned to the on position and in full choke when compression valve is engaged. 1 to 3 pumps on the primer on older saws. No primer needed on new saws. Use full choke until the engine begins to fire. When the saw starts, release the trigger and the engine to idle. Allow the saw to warm up before operating at top speed. Usually, this can be accomplished in 1 minute. Allow the saw to run at mid-range for 30 to 45 seconds before bringing it up to full throttle. Now is the time to bring the saw up to full speed, safely, for about 10 to 15 seconds. Allow the saw to return to idle before shutting it off. Starting any flooded saw. Place the saw in a stable position on the ground. Place saw in run position. Hold throttle wide open and don't let go. Pull saw until it starts, usually 10 good pulls. Rotary saw, ventilation. Husqvarna K12FD970. Details: will fit a 12 or 14-inch blade. 12-inch blade is preferred for ventilation. Has a 1-inch arbor and runs at 5,500 RPMs. Weight 24 pounds. Rotary saw blades. Desert Diamond 12-inch. 12-tooth carbide tip blade. Has the ability to cut membrane, stapled, and tarred roofing, asphalt shingles, fiberglass, drywall, and all wood products. Starting the saw. On-off button should be in the on position. Decompression button should be depressed. Warm start on. Choke needed. Cold start needs to choke. Choke should be out or out and then back in. Put saw into a high idle. This makes saw easier to start, especially in smoky conditions. Wonderful pulls, the saw turns over. Turn off choke. Press decompress. And start saw. Allow the saw to warm up before operating at top speed. Usually, this can be accomplished in 1 minute. Allow the saw to run at mid-range for 30 to 45 seconds before bringing it up to full throttle. Now is the time to bring the saw up to full speed safely for 10 to 15 seconds. Allow the saw to run to idle before shutting it off. Battery cutoff saw 9-inch, 60 volt, max DeWalt cutoff saw. The 9-inch blade allows for cuts up to 3 1/4 inches deep. Carbide tip blade allows for multi-purpose cutting. Useful when working off a ladder. Useful for cutting where smoke may choke out a gas-powered saw. Be aware of its limitations. Chapter 5. Extrication Equipment. Extrication Equipment. Hydraulics. E2. Hydraulics. Standard. Not waterproof. E3. Hydraulics. Squad 43 only. Waterproof. Spreaders. Max spread of 28.7 inches. 148,000 pounds of force. Cutters. Max cut opening 7.6 inches. The ram. 23.5 to 53 inches, has a 2-stage telescopic arm. Lithium-ion batteries, E2, 2 batteries per tool, 6 total, 25 volt, 5 amps, 40-minute runtime, 1 hour charge to 80%, 2 hour charge to full charge. Shoreline for continuous use. Lithium-ion batteries, E3, waterproof, saltwater, 2 batteries per tool, 6 total, 25 volt, 5 amps. 40-minute runtime. 1 hour charge will give you 80%. 2 hour charge to full. DeWalt Ripper Glass Cutter. 20-volt DeWalt drill with tip attachment for windshields and impact glass. Rhino Cutter. Battery-operated cutter for windshields and impact glass. Air Chisel. The Ajax tool. The air chisel is designed to rapidly cut heavy metal, including 1/4-inch mild steel plate, 3/4-inch mild steel bolts, automobile safety door lock bolts, vehicle doorposts, automobile roofs, vehicle and aircraft seat brackets, fiberglass, carbon fiber, aluminum, metal buildings, metal roofing, and sheet metal ducts in a matter of seconds. Can run off an SCBA bottle and use regulator. Can run off engine 43 air system, use engine 43 regulator. Operates at 90 to 125 psi. Lift bags, Squad 43. Aramid Max Force, 12-inch bag, 1. Has a lift capacity of 6.4 inches. Maximum weight of 6.5 tons. 20-inch bag, 2. Has a maximum lift of 11 inches. Maximum weight of 20.2 tons. 34-inch lift bag, 1. Maximum lift, 13 inches. Maximum weight, 29.9 tons. Lift bag operations. SCBA bottle to regulator at 115 psi. Black hose regulator to lift bag controller. Yellow red hose lift bag controller to lift bags. Tips. Crib extra space between bag to object to lift. Biggest bag on bottom when using multiple bags. Fill bottom bag first when using multiple bags. Crib to capture lift. Other lifting devices. Floor jack. 1.5 ton floor jack. Bottle jacks. 4 ton. 2 20-ton. Lift approximately height of jack closed. To release, bleed valve on front. May need pliers and put pressure on jack. Struts. Paratech Supporter X2. TVS. Twist lock vehicle stabilizer. 10,000 pounds with 2-to-1 safety factor. 40 inches to 65 inches. 30-inch extension. Max 95 inches. When checking the struts, the ratchet should be in line and no webbing should be wrapped around the spindle. This allows for quicker deployment. Paratech TVS 100 green. TVS twist lock vehicle stabilizer. 10,000 pounds with 2-to-1 safety factor. 47 to 60 inches. When checking the struts, the ratchet should be in line and no webbing should be wrapped around the spindle. This allows for a quick deployment. Paratech rescue strut. 40,000 pounds with 4-to-1 safety factor. Separate base, multiple tip options, and ratchet with J-hook. Chains. Hurst safety chain. All engines except Squad 43. Grade 80 chain, 3/8 inch, black in color with purple hooks. Rated for 64 kilonewtons. 2,600 pounds working limit. Not for overhead lifting. Grabby O safety chains. Squad 43. Grade 100, 3/8 inch chain. 10-foot double leg, blue in color with yellow hooks. Rated for 15,200 pounds max working load. 4-to-1 safety factor. 8,800 pounds max per leg. Overhead lifting, slinging, and tiebacks. Chapter 6. Hose, Nozzles, and Appliances. Hose. Engine hose load summary. 100 feet, 1.75" jump line. Ball valve shutoff with fixed gallonage fog nozzle. 160 GPM at 50 PSI. Two 200-foot, 1.75" pre-connect attack lines. Ball valve shutoff nozzle with 7/8 inch smoothbore tip. 160 GPM at 50 PSI. Or fixed gallonage fog nozzle. 160 GPM at 50 PSI. If rig has one smoothbore and one fog, the fog should be on the engineer's side of the rig. One 200-foot, 2.5 inch attack line, smoothbore nozzle. 4 50-foot, 2-inch high-rise bundles with ball valve shutoff and 1 1/8 smoothbore tip, capable of 265 GPM. 800 feet, 5-inch LDH supply hose. Stacked 250 feet, each starting right to left. 400 feet, 3-inch hose, reverse lay. Male off first. Used for standpipes, FDCs, and courtyard lays. Stacked 200 feet and 200 feet, starting right to left. Ladder and truck hose load summary. 100 feet, 1.75" jump line. Ball valve shutoff with fixed gallonage fog nozzle. 160 GPM at 50 PSI. Two 200 feet, 1.75" pre-connect attack lines. Ball valve shutoff nozzle with 7/8 smoothbore tip. 160 GPMs at 50 PSI. Or Metro 1 fog tip. 160 GPM at 50 PSI. If rig has one smoothbore and one fog, the fog should be on the engineer's side of the rig. One 200-foot, 2.5 inch attack line, smoothbore nozzle. 4 50-foot, 2-inch high-rise bundles with ball valve shutoff and 1 1/8 smoothbore tip at 265 GPM. 700 feet, 5-inch LDH supply hose, stacked 250 feet each, starting right to left. 400 feet, 3-inch hose, reverse lay, male off first, used for standpipe operations, FDC operations, and courtyard lays. Stacked 200 feet and 200 feet, starting right to left. Hose type, attack hose, 1.75", 2-inch, and 2.5-inch hose. Hose expected to enter hot zone. Key combat ready hose or equivalent. Construction, double jacket over one-piece extruded through the weave nitrile PVC. Hose, 1.75", inner diameter, 1.88 inches. Friction loss for 100 feet, 20 PSI. Coefficient, 6.5. Weight empty for 50-foot bundle, 20 pounds. Weight full for 50-foot bundle, 70 pounds. Gallons per 50 feet, 6. 2-inch hose. Inner diameter, 2.4 inches. Friction loss per 100 feet, 25 PSI. Coefficient, 4.2. 50 feet empty weight, 22 pounds. 50 feet full weight, 100 pounds. Gallons per 50 feet, 8. 2.5-inch hose. Inner diameter, 2.59 inches. Friction loss per 100 feet, 14 PSI. Coefficient, 2. Empty weight per 50 feet, 31 pounds. Full weight per 50 feet, 135 pounds. Gallons per 50 feet, 12 gallons. Supply hose, 2.5-inch to 3-inch and 5-inch hose. Hose used for supply only and not expected to enter hot zone. Key Echo 10 hose or equivalent, 2.5-inch. 2.5-inch hose is combat ready. Construction, thin wall EPDM liner, double jacketed. 2.5-inch hose, inner diameter, 2.59 inches. Friction loss, empty weight per section, 31 pounds. Full weight per 100 feet, 135 pounds. 3-inch hose, inner diameter, 3 inches. Friction loss, 25 PSI at 500 GPM. Empty weight per section, 38 pounds. Full weight per 100 feet, 375 pounds. Gallons per section, 18 gallons. 5-inch hose, inner diameter, 5 inches. Friction loss per section, 8 psi at 1,000 GPMs. Weight empty per section, 140 pounds. Per section, 1,000 pounds. Gallons per section, 100. Hose testing. Hose testing will be done annually by an outside company. New hose will be tested by EFR. Hose that is damaged or run over will be tested by EFR. Hose testing procedures. Attack hose. Charge line to 300 psi and hold it for 5 minutes. Supply hose. Charge line to 200 psi and hold it for 5 minutes. 1 3/4 attack hose. 2 wide hose bed, Sufton crosslays. Minuteman on left, flat on right. 1 wide hose bed, E1s. Minuteman on top, flat on bottom. Attack hose load principles. Hose is single stacked, not crossed over each other. This single stack is called an accordion because of its folds that look like an accordion. 2 possible ways to set up an accordion stack, just the reverse of each other. Flat load, male coupling on top, female coupling on bottom. Minuteman load, female coupling on top, male coupling on bottom. Hose loads are split, side by side, or a combination load, 1 stack on top of the other, in a half flat load and a half Minuteman load configuration. Minuteman is the half of the hose closest to the nozzle. Flat is the opposite half of the hose. Only difference is how we fit this into different sizes of hose beds, but the basic concept is the same. Same for all hose sizes, 2.5 inch and 1 3/4. 2 wide hose bed, supply. Start an accordion stack on the right side of the tray with the female coupling. Leave about 3 feet from the tray to make a connection on the truck. On the engines and ladder 42 will connect right to the truck when you start. Create a dump bite on the second bite. Ensure that this dump bite will actually dump the hose and not pull tight on the discharge connection. Continue loading until you reach 50 feet for a 200-foot pre-connect. Once you reach this point, create a halfway bite. Leave the coupling on the bite so it can be easily broken down for a vertical stretch option. Continue loading this single stack until you load 100 feet for a 200-foot pre-connect. 2 wide hose bed. Attack. Start another accordion stack with the nozzle first. Continue this stack until you load 100 feet for a 200-foot pre-connect. Keep the coupling out of the middle third of this stack. Having a coupling situated in the middle of this stack lifts the center of gravity to the load, making it more difficult to manage while being carried, especially in larger bundles. Connect the stacks together. Connect the nozzle and female coupling to discharge outlet once completed. Note, the Minuteman and flat load can be loaded in any order at the same time. Both sides are set up the same way. The Minuteman stack is always on the left side, and the flat is on the right. 2 wide stacks are designed to come off the truck on one side. Expect to lose 15 feet of distance when stretching from an opposite side if a second line is needed. 2 wide hose bed, apparatus view. The picture to the left shows the dump bite, the first bite after the coupling. The picture on the right shows putting the coupling in the dump bite. This is a preferred way to load this. It allows the crew to disconnect the lead 100 feet plus 50 feet of supply and complete a drop down to the engineer, who connects the 50 feet coming off the rig to the dropped section. Front jump line, attack line. Connect the female coupling to the discharge outlet and start an accordion stack. Create a dump bite on the second bite. Ensure that this dump bite will actually dump the hose and not pull tight on the discharge connection. Continue until you load all 50 feet. Set male coupling aside. Make an E-bundle with a 50-foot section of hose, approximately 4 feet in length. Start with the nozzle on your left heel and continue the load until all hose is bundled. Use a strap to keep the bundle together right behind the coupling. Fold bundle in half and place it in the front bumper. Connect an E-bundle, female coupling, to the accordion male coupling. Load first 50 feet flat with ears on each side. This helps to ensure that the hose clears the irons. Nozzle section is an E-bundle starting with a 4-foot length bundle and then hook up to the flat load. 1 wide hose bed, supply line. Connect the female coupling to the discharge outlet and start an accordion stack. Create a dump bite on the second bite. Ensure that this dump bite will actually dump the hose and not pull tight on the discharge connection. Continue loading until you reach 50 feet for a 200-foot pre-connect. Once you reach this point, create a halfway bite on the next row after the coupling. Continue until you load 100 feet for a 200-foot pre-connect. Place the male coupling out of the way for the next accordion stack. 1 wide hose bed. Attack. Start another accordion stack with the male coupling. Continue until you load 100 feet for a 200-foot pre-connect. Note, keep the coupling out of the middle third of this stack. Having a coupling situated in the middle of this stack lifts the center of gravity of the load, making it more difficult to manage while being carried, especially in larger bundles. Connect the upper and lower stacks together. Rear loads, 2.5-inch hose. In order to keep the 2.5-inch load as close to the same as a 1.25-inch crosslay, use the last 6 feet of the bed towards the rear of the rig for the load. Start by attaching the female coupling to the discharge. Then start an accordion stack on the right side of the tray. Create a dump bite on the second bite. Ensure that this dump bite will actually dump the hose and not pull tight on the discharge connection. Make another loop after the first coupling as the halfway bite. Continue loading until you reach 100 feet. Put the male coupling off to the side. Start the Minuteman stack, loading the nozzle first. Put the bail up so it won't get hung up in the bed. The optimum length for a Minuteman stack is 6 feet, while bed is 15 feet. Some of the trucks have a 6-foot marked in the bed or on the hose. Make a loop on the first bend, just above the nozzle. This will help the firefighter pull the stack out when deploying. Continue to load the hose until a full 100 feet Minuteman stack is complete. Connect the couplings of the Minuteman stack and accordion stack. Pull the Minuteman stack out from the bed just enough to secure it together with the strap. Pull the stack back onto the bed. 3-inch supply loads. Both engines and ladders carry 400 feet of 2.5-inch or 3-inch hose. This hose will be used for long lays, supplying FDCs, and supplying other rigs. This will be loaded in a reverse lay. Male comes off first. This will be loaded in 2 200-foot stacks so that we can shoulder the load when stretching around cars and to reduce drag. As with all our loads, start loading on the right to left so that the coupling will pull off from the left side. One variable to this load is on engine 49, since there's a pike pole compartment in the same area. On this rig, the first 100 feet will be loaded on top of the pike pole compartment, and the remaining 300 feet will be stacked on the left side. 5-inch LDH supply loads. Engines will carry 800 feet of LDH, and ladders will carry 700 feet of LDH. In order to make best use of space, limit coupling hang-up, keep hose from zigzagging in the streets, and aid the engineer in grabbing several bites to place hose on shoulder when handjacking. EFR will be loading in stacks rather than back and forth. To keep all hose loads consistent, the load will begin on the right side of the hose bed, and as each completed move is done, move it towards the left. This way, all hose will pull starting from the left of each bed. The engines will have approximately 200 feet in each stack, and the ladders will have approximately 200 feet in each stack, except for the last one, which will have 100 feet. Be sure to leave room at the front of the bed for each coupling. High-rise hose. EFR uses 50-foot bundles of 2-inch hose with 2.5-inch couplings for our high-rise hose. It's loaded in a modified FD&Y load. To fold it, be sure to keep the straps 12 inches away from the couplings in the end. This keeps the bundle clean and allows the packs to be connected without taking off the straps. This allows the team to set up the bundles while the officer walks around the floor below to ensure that the attack is being made from the correct stairwell. If the officer comes back and chooses to change stairwells, the bundles can be disconnected and easily moved because the straps were still in place. Miscellaneous hose. 3-inch hose, 50 feet. In the engineer's compartment. Donut roll or engineer roll. This is so both the male and female couplings are accessible for the engineer to easily set up for booster backup operations. Lay the hose out and fold it in half like you are starting an HR fold. Begin 12 inches towards the male coupling and start rolling towards the male coupling. 5-inch, 30-foot pony section. Start on right-hand side of the hose tray. Start about 3 feet from the hose coupling. Flat load the hose until you come to the second coupling. After all the hose is loaded, place the first coupling in a tray lined up with the second coupling. This allows the engineer to easily deploy the hose from the tray. Nozzles. EFR uses 160 as a target flow rate for 1 3/4 lines and a 265 GPM target for 2-inch and 2.5-inch lines. The 160 GPM flow meets the NFPA 1710 recommendation that the first 2 attack lines operating at a residential structure fire once all first alarm resources are on scene, should flow a minimum of 300 GPM. Several of the NFPA 1410 standard residential structure fire attack evolutions provide the first two operating handlines at a residential structure be 150 GPM each. This is logical given response and reflex times. NFPA 1221, NFPA 1410, NFPA 1710, and the NIST report on residential fire ground field experiments, potential for flashover, nozzle reaction, and responsibilities placed on the first arriving engine company. When applied to the residential structure referenced in NFPA 1710, a minimum single handline flow rate of 150 GPM coincides with the NFPA fire flow formula of NFPA 1710's 300 GPM first alarm flow rate and the heat produced at a residential structure fire of flow risk using a field estimate. The 150 GPM target minimum flow allows for further firefighting capabilities, giving a greater margin for safety that accounts for fire ground obstacles and conditions. One of the largest contributing factors of any well-thought-out GPM delivery rate is kinks in the fire ground, short stretches, car tires, unsecured doors, narrow hallways, etc. Looking at external studies, several common themes are found. The solid stream has the ability at similar initial flows and lower nozzle pressures, 50 psi, to maintain a higher average flow when kinks are imposed. As the required nozzle pressure increases for fog nozzles, the ability to maintain a flow decreases when kinks are imposed on the hose line. In other words, as the required operating pressure for a fog nozzle increases, it is more susceptible to flow reduction due to kinks. The 160 GPM rate leaves some room for kinks with the understanding that we keep using a lower PSI rated insert for our combination tips. This study is a look at our current nozzles as they work with our current updated hose specs and configuration. EFR chose an attack nozzle that has several key characteristics. Desired flow of 160 GPM for inch and 3/4 lines. Desired flow of 265 for 2-inch and 2.5-inch lines. Simple in design, simple repair and maintenance program. Full ball valve shutoff over split ball shutoff. Light to heavier nozzles produce more nozzle whip. Allow for both fog and smoothbore tips. Be able to extend the line from the tip at a reasonable flow rate. Work well with our current Key Combat Ready hose, 1.88 ID. And inherently kink resistant. Inch and 3/4 attack lines. 1.5 ball valve shutoff. Full round ball. TFT F140F or 1.5-inch XD shutoff. 7/8 tip, 161 GPM at 50 PSI. Nozzle reaction 60. FSS8 or 187 XD SB. Fixed gallonage fog nozzle. TFT ME1. TO or Chief XD, 160 at 50 PSI. This configuration allows officer to choose smoothbore or fog-based on crew choice or incident without affecting pump pressure. The 200 GPM at 75 PSI fog, when pumped at 50 PSI, flows 163 GPM. Lines can be extended by shutting line down, spinning off tip, and connecting new line with nozzle to the end of the nozzle. Lightweight but durable, short base, no integral slug to avoid increased flow rate if used for extending line. 2.5-inch attack lines, 2.5-inch ball valve shutoff, full round ball, TFT J140F or Elkhart 2.5-inch XD. 1 1/8 tip, 266 GPM at 50 PSI with a nozzle reaction of 99 pounds. FSS 10 or 187 XD SB. 250 GPM at 50 PSI fixed gallonage fog nozzle tip. TFT ME2 TO or Chief XD. 250 GPM at 50 PSI. This configuration allows officer to choose smoothbore or fog-based on incident without affecting pump pressure. Lines can be extended by shutting down the line, spinning off tip, adding an increaser, or connecting new line with nozzle to the end. Can also add inch and 3/4 line to the end to use for mop-up. Lightweight but durable, short base, no integral slug, to avoid increased friction loss if used for extending line. 2-inch high-rise packs with 2.5-inch couplings. 2.5-inch ball valve shutoff, full round ball, Elkhart ELK DB 375 AT 1.125 plus XD. No stream straightener. Short 1 1/8 tip, 266 GPM at 50 psi. Nozzle reaction 99 pounds, included above. Short 1 1/4 inch tip in high-rise bag, 325 GPM at 50 psi, with a nozzle reaction of 123 pounds. Elkhart ELK 6672201. Short 7/8 tip in high-rise bag for smaller fires, 161 GPM at idle. Elkhart ELK 667-17001. This configuration is slightly heavier and more rugged than pre-connect nozzles, but they are similar in design and interchangeable. Lines can be extended by shutting line down, spinning off tip, adding an increaser, and connecting new line with nozzle to the end of the nozzle. Can also add 1 3/4 line to end to use for mop-up. This nozzle is lightweight but durable. Short base, metal horseshoe style bail, and no integral slug to avoid increased friction loss if used for extending line. Items in the high-rise bag: gate valve, elevator keys, spanner wrenches, wedges, hose rope tool, SCBA bottle strap, sprinkler tool, spare smooth bore nozzle with 1 1/8 tip, 7/8 tip smooth bore tip, pressure gauge with elbow, reducer, webbing, increaser, lead section of high-rise pack in female coupling, master streams, aerial devices. EFR has chosen to use an automatic fog nozzle on the elevated master stream on ladders. This will allow the pattern and GPM to be controlled by the engineer on the ground. Should water supply become a problem, the automatic nozzle will adjust itself to maintain a good stream. Deck gun. EFR has chosen to use stack tip setup on the deck guns on the engines. There is a gate valve before the nozzle. This allows the engineer to change the deck gun and then go up and aim prior to any water flowing. This reduces the amount of water wasted before the deck gun is properly aimed. If possible, the deck gun should be left in an up position to allow this plan to take place. The stacked tip is the most common set of smooth bore tips that comes with a master stream. Its name derives from the fact that it consists of 4 tips connected into one stack, which is then attached to the master stream. The tip sizes and the corresponding flow rates are based on an 80 pound per square inch PSI nozzle pressure. EFR has chosen the 4 stack tip package. 1 3/8 inch, 1 3/8 inch smoothbore tip is the initial tip to reach the desired target flow rate of 500 GPM. 1 3/8 smoothbore tip is the initial tip to reach the desired target flow of 500 GPM. 1 3/8 tip, 502 GPM. 1 1/2 inch tip, 598 GPM. 1 3/4 tip, 814 GPM. 2 inch tip, 1063 GPM. Brush trucks. EFR uses the TFT Midmatic automatic nozzle on its brush trucks and as foam nozzles. The nozzles operate at 75 psi. Automatic nozzles are complicated in design and require regular maintenance to assure that it performs properly. The design is one with a spring that tries to maintain a good quality stream no matter what the GPM flow rate is. The problem is that the firefighter is unaware when he or she may be flowing less than the desired flow rate because of the automatic nozzle maintains its stream quality. Underpumping and kinks can result in pressure as low as 80 GPM with no obvious sign to the firefighter. Nozzle reference for nozzle reaction: 1 3/4 hose, nozzle 7/8 tip, GPM 144, nozzle reaction 48 pounds. 1 3/4 hose with a 7/8 tip nozzle at 40 psi flows 144 GPM and has a nozzle reaction of 48 pounds. At 50 psi, it has 161 GPM with a nozzle reaction of 60 pounds. At 60 psi, it has 176 GPM with 72 pounds of nozzle reaction. 1 3/4 hose with 15/16 nozzle at 40 psi, 165 GPM with a nozzle reaction of 55 pounds. At 50 psi, 185 GPM with a nozzle reaction of 69 pounds. At 60 psi, 202 GPM with a nozzle reaction of 83 pounds. 2 1/2 inch hose with a 1 1/8 tip at 40 psi flows 238 GPM with a nozzle reaction of 79 pounds. At 50 psi, 266 GPM with a nozzle reaction of 99 pounds. At 60 psi, 291 GPM with 119 pounds nozzle reaction. 2.5-inch hose with 1 3/16 tip at 40 psi flows 265 GPM with 89 pounds of nozzle reaction. 2.5-inch hose with a 1 3/16 tip at 40 psi flows 265 GPM with a nozzle reaction of 89 pounds. At 50 psi, 296 GPM with 110 pounds nozzle reaction. At 60 psi, 325 GPM with 133 pounds of nozzle reaction. 2.5-inch hose with 1 1/4-inch nozzle at 40 psi produces 294 GPM with 98 pounds of nozzle reaction. At 50 psi produces 328 GPM with 123 pounds of nozzle reaction. At 60 psi produces 360 GPM with 147 pounds of nozzle reaction. Firefighting nozzle reaction parameters: 1 firefighter per 60 pounds of nozzle reaction, 2 firefighters per 75 pounds of nozzle reaction, and 3 firefighters for 95 pounds of nozzle reaction.